In Power Query, I'm aware of two main approaches for performing approximate match lookups. The first method uses mostly table transformations, such as merge, sort, and fill down. The second method adds a column and performs the lookup row by row. But which is the fastest? In this video, we're going to build both solutions and then compare them to find out. So if you're ready, let's get started. Here we are in Excel and we have our scenario. On the left we have a table called data and it contains values for each row. On the right we have a table called discount and this contains the discount which can be achieved and the threshold. So any value over 50 gets a 10% discount. Anything over 75 gets a 20% discount and anything over 100 gets a 30% discount. Our goal is to return a table which contains item, value, discount, and final value, which is the value minus the discount. I've already loaded these tables into Power Query, so now let's make a start with method number 1. Method 1 performs entire table transformations. If you want to find out more about how this method works, you can find links in the descriptions box below. As you can see, we have our data table and also our discount table. We're going to start by referencing our data table. So I'll right click on data and then come down to a reference. And we're going to call this query method 1. Next, we're going to merge our method 1 and our discount tables. So from the home ribbon, I can click merge queries. We have our table of method 1. And then in our second table, we want discount. And we want to merge on the value and threshold columns. And also for the join kind, we want to use a full outer. I'll then click OK. This now adds a discount column and we want to expand this column. So I'll click on the double-headed arrow. We don't want to use the original column name as prefix, but we do want both of our columns. I can then click OK. We now have 4 columns. We have item and value, which contains the values at the top, and at the bottom we have our threshold and discount values. Now discount has come across automatically as discount.1. Let's edit our M code to change that to just discount. Unfortunately, using this method, we have null values in both columns, but we don't want them to be null. We want them to be 0. So I will select both columns. And then from the transform ribbon, I'll select replace values. And we want to replace null with 0. I can then click OK. We're now ready to create a combined value column. To do that, I'll go to add column and select custom column. Our column name is going to be combined value. And then our formula is going to be our value plus our threshold. I'll then click OK. And that now adds our combined value column. Now so far this method may seem a little bit crazy, but the next steps are where it all comes together. Using the combined value column, we want to sort in ascending order. When we do that, we now have all of our values and we have all of our discounts and the places which they start. If we now right click on our column and select fill and down, we now have the discount for each of our values. In our item column, the null values are where we introduce our threshold bands. We no longer need those, so we can right click on the value, text filters, and does not equal. That now removes all of those null values. We're now ready to calculate our final value. So I'll click add column and then custom column. I'm going to give this the name of final value. And then for our formula itself, we want the value multiplied by opening bracket 1 minus the discount. And then close the bracket and click OK. And that adds our final value column. You'll notice this doesn't have a data type, so let's add that. At the end, I will add type number. And when we commit that, we now have a number data type. That now includes all of our calculations, but we don't need all of these columns. Let's select Item, Value, Discount, and Final Value, and then from the Home ribbon, we can go to Remove Columns and Remove Other Columns. And that's it! We've now performed our approximate match lookup to get our discount and our final value. That was method 1, which used table-based transformations such as merge, sort, and fill down. Now let's move on to method 2, which uses a row-by-row calculation inside a new column. We're going to start by referencing our data query once more. I'll right-click and select Reference. And then we want to call this query method 2. Now, this is a row-by-row calculation. So let's start by simulating how this would work, and then we can use that code in our solution. Let's think about alpha, which has a value of 88. We're then going to come to our discount query, and we want to filter our threshold based on a number filter where it is less than or equal to, and the value that we want is 88. I'll then click OK. This reveals all of the thresholds which are less than our value. We only want our discount column. So in square brackets, I'll enter discount. We now have a list that contains those 3 discounts. Now, because our discounts were in order, we only want to apply the last value. So at the start of our formula, I'm going to add list.last, open your bracket, and then we can close that bracket at the end. And when we commit that, we now get the 20% discount that would apply to the value of 88. For the moment, we are just going to copy this piece of M code. We will be using this later in our solution. But we don't need this step anymore, so we can delete our filtered rows step. Now let's come back to our method 2 query, and we're going to go to Add Column and Custom Column. We're going to give our column the name of discount, and in there we are going to paste the M code that we created earlier. Now there are some changes that we need to make to this. When we created this line of code, change type was the name of the previous step. Well, we don't want to use change type, we want to use our discount table. We also hard-coded the value of 88. We also don't want that. We want our value column. The other element we need to change is our each keyword. Each is syntax sugar to represent a function which is performed row by row. But because we are adding a custom column, that also uses the each keyword. So we need to convert this back into a standard function. So we're going to delete the each keyword. I'll then enter an opening bracket, and we're going to use a variable name of row. This represents each row in our discount table. I can then close that bracket. But to complete our function, I need the goTo operator, which is represented by equals and greater than. So that piece of code is equivalent to our each keyword. We also need to use row when we refer to our threshold column, because that is the column which was contained in our discount table. I can then click OK. And that adds our discount column. This doesn't currently display as a percentage, so let's add percentage type. And now we have our discount percentage. Finally, let's add our final value column. I'll click on the custom column. The column name will be final value, and then for our formula, we want our value multiplied by 1 minus the discount. I'll close the bracket at the end and click OK. That now creates our final value column, and we want this to be of type number. Before we finish, there's one other thing that we need to do. In our step that created our discount column, we are calling our discount table for each row of our method 2 table. Therefore, this will be very slow to calculate. What we want to do is to buffer our discount table. That means our table will be held in memory so that it's easier and faster to access. To do that, we're going to come across to our discount query. We're going to click on the FX icon and we're simply going to enter table.buffer. We can reference our previous step of change type, and that's it. That is all we need to do. So we now have method 1 and also method 2. That's both of our methods, so now let's load them into Excel and find out which is the fastest. Here we are in Excel and we have the results from method 1 and method 2 loaded as tables. We're now going to perform various speed tests on these two methods. To run these tests, I'm going to use Monkey Tools. I have the Monkey Tools add-in, and in there we have Time Sleuth. Now, if you want to get hold of the Monkey Tools add-in, I'll leave a link in the descriptions box below. Time Sleuth is a premium feature, so you will need a license to use this feature. I'll select Time Sleuth. In here, we can see both of our queries. I'm going to select method 1 and say that we want to chart variation. We're going to use 10 trials. We're going to ignore privacy. I'll then click detailed refresh. This now calculates our query 10 times and gives us our results. I'm now going to do this for method 2 and also for varying numbers of rows. I'll be back in a moment with the results. And here are our results. We have time along the vertical axis and the number of rows along the horizontal axis. As you can see, method 2, which is the row-based method, is consistently slower than method 1, which was the table-based method. And this was based on tests using 26, 1,000, 10,000 and 100,000 rows. I also looked at the impact of the number of thresholds. I tested at 4, 100 and 1,000 thresholds, and as you can see, method 1 was significantly faster than method 2, especially as the number of thresholds increased. So overall, even though method 1 may seem more complex because it has more steps, it does have a faster refresh time. If you liked this video, then you really should subscribe and get notifications so you don't miss any of our future videos. Thanks for watching, and I'll catch you next time.